Let us talk about the next topic, data warehouse. It is something similar to database, but it has a totally different purposes. So if we take a look of this graph again, you will understand that starting from different sources of the database, we want to pre-process it. We want to integrate all the data into what we call a data warehouse. Obviously, it has a very different definition from data warehouse to the databases. And therefore, in this chapter, we want to understand what is a data warehouse. So this is the outline, starting by talking about what is a data warehouse, define the data warehouse, and then we want to look into the multi-dimensional data model, which describes the data warehouse. We want to understand what is a multi-dimensional data model talks about, and we will also take a look of brief coding to understand how does it looks like in comparison with the database. And finally, we will look into the data warehouse architecture. In my previous meetings with UCA, I actually realized UCA has two data warehouse store the historical data about the UCA, so that when the higher administrations want to make some decisions, they would have a place to look into their data, analyze the data, and then supporting their decisions. So obviously, data warehouse is something very important aside from the regular databases. So let us take a look and understand what is data warehouse. Loosely speaking, if we want to define a data warehouse, a data warehouse refers to a database that is maintained separately. So obviously it's separate from the operational database, from an organized operational database. And why do we want to do that? In this case, to understand it, we need to define the data warehouse officially. So let's take a look at this. A data warehouse is a subject-oriented. It has some specific targets that you want to understand. So it collects a separate database based on subject-oriented purposes. It is integrated. So if you have multiple sources of the database, you need to collect them, you need to merge them, forming a separated subject-oriented data warehouse. It is also time variant. Time is an important dimension in data warehouse because you want to use time to help you understand the changes. And so that is always a very important dimension in the data warehouse. Is also non-volatile. Collection of the data in support of management's decision-making process. Each one of these four important keywords, we will have a slide to discuss them a little bit deeper. So first of all, subject-oriented. It is organized under a major subject, such as customer. So the data warehouse is about customer. Then you want to collect everything about the customer into the data warehouse. It can be products, it can be sales, it can be students, it can be teachers. So all of these are important in terms of one major subject that they want to collect about. Focusing on the modeling and analysis of the data for decision makers. So not everybody is able to use the data warehouse. It's not meant for everyone. It's meant for someone who can make the decisions, and they need something to help them to make those important decisions. And therefore, data warehouse is always a very good tool to help people making important changes. So it's not on daily operations or transaction processing. Those are not the main focus of the data warehouse. It provides a simple and concise view around a particular subject by excluding all the data that are not relevant in the decision process. And therefore, that's one of the major focus regarding to the data warehouse. It is also integrated. Construct by integrating multiple heterogeneous data sources, so they can come from many different places, such as registrar office in terms of UCA. It can also collect the data from the financial supports departments. It can also collecting about a dormitory history of all of these informations if we are looking at some student related topic. So it is constructed again by integrating multiple heterogeneous data sources, relational database, flat files, online transaction records, etc. All of these can be considered as the heterogeneous data sources. Of course, how to combine them together is an art or to help creating the data warehouse. Data cleaning and data integration techniques are crucial in this step. So you need to make sure that consistent in naming conventions, make sure the people who is going to use it understand what's the name of each attribute, why are they relevant, why are they important, and of course you need to remove all of those duplications. You need to encoding structure, attribute measures, etc. among different data sources need to be clearly defined as well as interpreted. When data is moving from data warehouse, it is converted. So once you store in the data warehouse, it is very well designed already so that the decision makers can easily retrieve the clean set of the data that are integrated from heterogeneous data sources. It is time variant. The time horizon of the data warehouse is significantly longer than the operational systems. So if you are looking at operational systems, you probably want to make sure all of these today's transactions are processed successfully, or you want to record some quarterly information and maybe yearly information. However, in data warehouse, it is not focused on the current value data because that's what operational database focus on. What data warehouse want to focus is providing the information from a historical perspective, possibly the last decades of the informations. They want to gather all of those to find a trend or to find the important information hidden inside of the data warehouse. So finally, it's a non-volatile. So what does that mean? It means a physical separate store of the data transforming from the operational environment. So like in my UCA, you go in over there, sign up the courses, and then making all the changes. Almost every semester, new courses are posted, new semesters happening. So that is what we call the operational database. What data warehouse trying to do is separate from that operational environment. They want to keep track of the information. So like in the end of every semester, they want to transform the data into the data warehouse, understanding that how many courses that we offer, how many students are registered in each courses, and what is the trend. Maybe, for example, database has a trend getting increase of more and more students registered in. Previously, has usually one section has about 10, 15 students, but now almost every section hits the maximum, which is 25 students. So maybe based on this information, we can create a model to predict what's going on, and maybe we will be able to offer one more section in the future to maintain the ratio of the student versus faculty ratio in terms of the UCA standard. So a lot of things can happen over here. So operational up to data does not occur in data warehouse, so we don't update it. Once we store, clean it, integrate everything, store in data warehouse, it stays over there forever. So it does not require transaction processing, recovery, concurrency control mechanisms. So they can reduce, they can take away of those overheads and then increase the performance in terms of retrieving the data. So it requires only two operations in data accessing. One is the initial loading, the other one is access of the data, so that they can focus of all of their resources into these two major purposes of the data warehouse. So in sum, data warehouse is a semantically consistent data stores that serve as a physical implementation of a decision support data model and stores the information on which an enterprise need to make strategic decisions. It is always separated from the operational database, and it has those four important properties regarding to the data warehouse. Traditional heterogeneous database integration. So if we want to understand the difference between data warehouse versus the other kind of database, which is called a heterogeneous database integration, it's basically a query-driven approach. So you can build up the wrappers, meditors to on top of heterogeneous database so that they can make queries from those database quickly, which combines many different kind of things all together. However, data warehouse is update driven. It's a high performance model that information from heterogeneous sources is integrated already. So you can see that in the heterogeneous database integration, they need something called wrapper of mediators to combine the data from different sources and then find a output from it. For example, if you go to Google, search for some hotels, it can easily gather a lot of different websites, finding all of the websites price for the same hotel. And then that is the idea of building up the wrappers to go through all of the other websites, such as say Marriott, go through hotels.com, go through Expedia, and find all those informations out and make so that you can make a very quick query on the heterogeneous database integration. However, for data warehouse, that is not necessary because when you put data into the data warehouse already, they are well integrated and they have been stored directly from those data already. So that the main purpose for the data warehouse is for direct query as well as the analysis. And that's what makes OLTP versus OLAP very different. For OLTP is online transaction processing. So what you guys have learned so far regarding the database, those kind of things is considered as OLTP, the major text of the traditional database, DBMS. So it's going to do day-to-day operations, purchasing, inventory, banking, manufacture, payroll, registration, accounting, etc. Those are considered as the DBMS work that we are studied in database class. For data warehouse, it's focused on OLAP, so which is online analytical processing. So the major text of data warehouse system, which has only mainly two things: store the data as well as access the data in a high performance manner. So data analysis and decision makings are the main focus on the OLAP, online analytical processing tools. So here is the major difference between the OLTP, which is a regular database, versus the data warehouse. The users for OLTP is clerk, IT professional, maybe end users, etc. However, for OLAP, which is data warehouse, is focused on knowledge worker. For the function in the OLTP is on day-to-day operations. OLAP is focused on decision support. Database design-wise, the OLTP is application-oriented, which is things that we have learned in the relational database design. For the OLAP is focusing on subject-oriented. So in the next part of the data warehouse, we will start looking into the database or the data warehouse design. You will see that the subject, the main focus is going to be on one thing, and everything is built on that subject. The data stores in OLTP are concurrent data, up-to-date data, flat, relational, isolated data, etc. For OLAP, which is data warehouse, is historical data, summarized data, multidimensional data, integrated data, and consolidated data. Usage for OLTP is going to be repetitive, so they want to use things repeatedly. So people making the purchases online, they can successfully pay their bills as well as retrieve the information about their order, etc. But for OLAP, it's going to be ad hoc. It's designed for the people who needs to use it. Of course, when people is not making the decision, is probably just sitting over there gathering the data until the people who needs to retrieve the information from the OLAP or data warehouse. OLTP need to deal with read, write, index, hash on primary keys, etc. OLAP is using scans, lots of scans to get the informations instead of like read and write, instead of write majority. So it's going to put the data in, retrieve the necessary information. Unit of work is usually short, simple, and transactions. For OLAP, it requires more complex queries to get the data chunk that you really need. Number of records for OLAP is tens of the records, but for OLAP has millions of the data, so it's actually pretty large. Several thousand of the users using the OLTP, or even tens of thousands. But for OLAP, it's much smaller group of people who can use it. And you can see the database size is going to be a big difference in database design. 100 megabyte to gigabyte is going to be satisfying the OLTP operations. For OLAP, it can go from gigabytes to terabytes, or even petabytes, so that it can cover more informations. And of course, you don't retrieve all of those data at one operation. You want to pick up the informations that you are interested in to get a smaller area of that to apply for data mining operations or decision support operations. The metrics is going to be focusing on transactions throughputs. For OLAP is on queries throughput response. To get the data that you need from this large amount of data, it requires some high performance operations, and that is going to be the important key things on the data warehouse. So questions. Why not perform online analytical processing directly on such database instead of sending additional time and resources to construct a separate data warehouse? So, which means that you already have the database available. Why would you want to spend time and money to build a separate one? Obviously, it's going to cost you more overhead. In other words, why does UCA wants to build up two data warehouse? Why not just using their regular database operations? Because data warehouses can remove all of those overhead and then use to build up the high performance for both systems. If you want to operate those things on the original database, such as UCA, that's doable. However, you can see that you will have overheads. You will reduce the performance for the regular operational database. And you don't want that because you want to make sure students can sign up their courses successfully. Any changes that may happen in the UCA World Network, they can happen quickly, and you don't want to have another huge analytical performance database to share the resources that your daily operational database. So DBMS term for OLTP, it can has its access method, indexing, concurrency control, etc., as well as the recovery operations. Those are the important key things for the OLTP, but not for OLAP or the data warehouse. And that's why separating the two things up can maintain the performance on both sides, and that is what we want, and that's why we want to make them separated.